Hello and welcome to the 4.4 optimization notes. This is a section where we use derivatives to help us answer some real world questions. But before I talk about the calculus, I want to talk about my friend named Bob. Now, Bob is a true American, but Bob has a saying. Okay, here's Bob's saying. Bob's saying. And his way of doing things and working is maximization through minimization. Maximization through minimization. And, you know, when I think of that, maximization through minimization, I think of maximizing something by doing the least amount of work. Okay, so you know, it goes with anything. It goes with work. It goes with school. You know, things that you can think of, like what's the maximum amount of grade that I can get with the minimum amount of work? What's the most money I can make without the least amount of work? Those kinds of things. And so you have kind of this like business application. Okay, you have a business application. Business application. Okay. And the business application is that we want to maximize our revenue. So maximize revenue, and that's the money that we take in, revenue. And we want to minimize our cost. Okay, and this will in turn maximize our profit. Okay, that's besides the point. Okay, well, let's just look at a couple of you know, real world examples. Let's think of like mowing lawns. Okay, and let's just think about this, like the number of lawns and then the profit. Okay, value of what we got. So you've got this, you know, you have this linear model. You know, let's say you mow, for every lawn that you mow, you earn, you know, $40. Okay, so, you know, every time you mow a lawn, you earn $40. Okay, and so that's just a linear model. That's just something where, you know, you just have to, you know, keep doing the job, you keep making money. Okay, but let's think about something else. Let's think about like iPhone 6S sales. 6S sales. Okay, and you want to maximize, you know, the number of iPhone 6S's that you sell. Okay, so then you have to produce enough. Okay, so if you think about this, you know, the number of phones produced, okay, may have some sort of effect like this. Okay, where if you sell a certain number of phones, then you will maximize your sales. Okay, so you know, something like that, where you know you've got all these different factors that play into like you know, a business such as selling iPhone 6S's. They've got a lot of people that work on this and crunch numbers and, you know, think about the market and that kind of stuff like that. So that's what you use this for. But you can model these situations and you know, use some calculus to solve the problem. So I'm going to show you guys a couple of just basic problems here and kind of show you the general idea. And the first one we have is this, where you have to minimize your perimeter. Okay, so if we read this, it says, what is the smallest perimeter possible for a rectangle whose area is 16 inches squared? And what are its dimensions? Okay. So let's zoom in here, and let's come over here and let's label this as this rectangle as X and as Y. Okay, my height X, my width Y. And so what we want to do is label that picture so at least we have those measurements. Now, if this is a rectangle, then this is X here, and this is Y. Okay. So the reason why I did that is because I have a perimeter equation here. Okay, I can write this equation for perimeter. P is equal to 2x plus 2y. Okay, And so I'm going to call this my primary equation. Okay, I'm going to write that this is my primary equation. Okay, this is the equation I'm trying to minimize. Okay, I'm trying to minimize this. Trying to minimize my perimeter. Okay, so the other thing that I know that we're given is that we're given the area. We know the area of this rectangle has to be 16 inches squared. So I'm going to come over here and I'm going to write this. I'm going to write my secondary equation. Okay, my secondary equation. Okay, and that's just going to be x times y is equal to 16. Okay, and this is for my area. All right, so we have these two equations. Okay, we have our primary equation, we have our secondary equation. And I know that I know how to call them primary and secondary because primary means this is what we're trying to minimize, okay? The secondary equation is just another equation that we can write based off of what we're given, okay? And so if I want to minimize my perimeter, if I want to minimize something, I can do the first derivative test to do that, to figure that out, okay? So I want to take the derivative of my perimeter, but I've got two different variables, and I just need one. And this is where that secondary equation comes in. So what I can do is I can solve this area equation for either x or for y, and then substitute it into my perimeter equation. Now I'm going to go ahead and solve this equation for y, so I can just use x. Okay, so I'm going to come in here, and I'm going to go ahead and divide both sides by x here and solve for y, so I get y is equal to 16 over x. Okay, so I can now take this and substitute it in for y over here. Okay, so I'm going to write my perimeter. Perimeter is equal to 2x plus 2 times y, but y is 16 over x. Okay, so if I want to take the derivative here, I'm going to simplify this a little bit. So I get 2x plus 32 over x. Okay, but if I'm going to take the derivative, I don't really want to use the quotient rule. I'm going to do 2x plus 32 times x to the negative 1 power. Okay, and so if I take this derivative here, if I get p prime, that's going to give me 2 minus 32 times x to the negative 2. Okay, and so if I wanted to simplify this even further, I would just say p prime is equal to 2 minus 32 over x squared. Okay, so this is my derivative. Okay, and what I want to do is I want to set this equal to 0. I want to find some critical points here. Okay, so I'm going to do that. I'm going to do 0 is equal to 2 minus 32 over x squared. Okay, I'm going to add 32 over x squared to both sides, 32 over x squared. And so I get this. I get 32 over x squared is equal to 2. If I multiply both sides of this by x squared times x squared, then I get that 32 is equal to 2x squared. Okay, if I divide both sides by 2 and by 2, I get 16 is equal to x squared. And so if I take the square root of both sides, I'm just going to get that x is equal to plus and minus 4. Okay, now because we're dealing with a distance here, we're just going to have to use x is equal to 4. Okay, that's the value, and that's a critical point. Okay, so now, typically what we would do is we would do the first derivative test. You'd make the table and test some points on either side of 4, that would give you, the sign of the derivative, and then you can tell if it's increasing or decreasing. But I'm going to use the second derivative here, okay? So let me write down what my derivative was. P prime was equal to 2 minus 32 times x to the negative 2, okay? That information, we've found that over here, okay? And I'm going to use this because I'm going to take this derivative. Okay, if I find the second derivative, if I find p double prime, then that's just going to give me positive 64 times x to the negative 3. Okay, And so what I can do now is take my second derivative, p double prime, which is 64 over x cubed, okay, and I can plug in 4 into that. I can plug in this critical point here, okay, and so what I'm going to do is I'm going to find p double prime of 4, all right, and what this shows me is that I get 64 over 4 cubed, okay? And so what this ends up giving me is a positive number, Okay, so because that's positive, then I know that we're concave up. And if I'm concave up, then what has to go at this point right here? This has to be a minimum value. Okay, so this is using the second derivative to do that. That's actually in your second derivative notes, but it's not in the video. So we're going to talk more about that. But now we need to go ahead and just find the dimensions. Okay, so if my dimensions, if I know what x is, if I know that x is equal to 4, okay, then I can come in here and I can solve for y. I can plug that down here, and I get that y is equal to 16 over 4, which is equal to 4. So then my answer that I would write is that my dimensions for this rectangle would be a 4 by 4. Okay, and it'd be 4 feet by 4 feet because it's 14 feet squared. Okay, so that's that problem. I hope that this video helped make a little bit of sense of what's going on. We're going to do a lot of problems like this, but this is the main idea. Okay, so I know that this is a new idea down here, but we're going to keep working at it and keep talking about it. So stay tuned.